Today we're going to continue to graph sine and cosine, and we're going to add translations. So the general formula is going to be a sine bx plus c plus k or plus d. I just use k because that's what your book uses. Cosine, the same thing. So amplitude we've already talked about. The calculation for amplitude is the absolute value of whatever the A is. Its definition is the distance from the midline to period is 2 pi divided by whatever the B value is. And its definition is how long it takes to complete one cycle. Phase shift. The calculation is going to be negative C over B. And it would be what the value would be here if we were to factor out the B. That's where this value is coming from. This is going to be the horizontal translation. And a vertical shift is whatever the K value is. And that's exactly what it sounds like. It's going to be the vertical translation. So it's going to match the same transformations we saw earlier in the semester, where if you add a number on the outside, it's going to move it up and down. If you add on the inside, it's going to move it to the left. If you subtract, it's going to go to the right. This formula reflects that. So whatever this is, if it's a positive phase shift, it's going to go to the right. If it's a negative phase shift, it's going to move to the left. So our parent graphs are sine, cosine, and then negative sine and negative cosine. So I'm going to graph each of these, and then we'll start doing others. So this is going to go from 1 to negative 1 on all of these. Okay, and we split this into 4 equal pieces. So this is pi over 2, pi, 3 pi over 2, and 2 pi. Pi, 2 pi, 2 pi. So let's graph these 4. So we have 5 points for each of these, 5 critical points. Sine starts at the midline, goes up, midline, down, midline. Negative sine starts at the midline and then goes down first, then up. Cosine is going to start at the maximum, go to the midline, to the minimum, to the midline, to the maximum. Negative cosine is going to start at the minimum and cycle through those 5 points. So these 5 points must be clearly labeled on your graphs to get credit for them. Okay. So we're going to identify the 4 attributes, amplitude, period, phase shift, and vertical shift, and then we will graph. Our amplitude is going to be 1. The period is 2 pi over 1, so just 2 pi. This one has a phase shift of negative C over B. So that's going to be negative pi over 2 over 1. So negative pi over 2, and there is no vertical shift here. So this graph is going to be our same regular sine curve, but it's going to be shifted to the left pi over 2. So when I draw my axes here, I'm going to leave some room in the negative territory because this is going to be moved. My maximum is 1, my minimum is negative 1. And I'm going to graph my I'm going to start, ignore the phase shift for just a minute. The period is 2 pi, so we're still going to go through 2 pi, cut that in half, cut that in half. So this is pi over 2, 2 pi over 2. This is 3 pi over 2. But my graph is going to be moved to the left pi over 2. So since this distance is pi over 2, that would make this negative pi over 2. So we're going to take my sine and we're going to shift it back. So the 5 points, rather than starting my cycle at 0, I'm going to start my cycle here at negative pi over 2. Then go through my 5 points. So this is sine shifted to the left pi over 2. My next one, notice the equation looks pretty similar. It's going to have an amplitude of 1, a period of 2 pi. The phase shift this time is going to be negative pi over 2 over 1, or a positive pi over 2. So this one's going to be moved to the right pi over 2. So this is 1, this is negative 1. For this one, when I'm marking this axis, since I know I'm going to be moving it to the right, I'm going to leave a little extra room here. So rather than putting the 2 pi out here, I'm going to put it like right here. So there's 2 pi. I'm going to cut that in half, which is pi. Cut that in half, which is pi over 2. 3 pi over 2. Now, your two options would be to graph starting here and go through your points and then just backtrack, or add 1. So if this is pi over 2, we're going to do 3 pi over 2, 4 pi over 2. That would make this one 5 pi over 2. So when I graph this one, I'm graphing a sine, so it's going to start at the midline, but rather than starting here, it's going to start here. So this is going to be 0, up, down, midline, up. Okay, or like I said, you can start here and just backtrack, because this thing is infinite. I just need to see one full cycle. What part of the cycle is, I don't care. You could go back and graph here and graph here. It's going to keep going. So you could do this, you could do this, you could graph more. Just at a minimum, you need the one cycle. All right, so we're adding more complexity to the equations. Amplitude here is going to be 3. The period is going to be 2 pi divided by 2, which is pi. My phase shift is going to be negative pi over 2 over 2, negative c over b, which is going to be negative pi over 4. We do not have a vertical shift. So again, when I'm graphing this, since I'm going to be shifting it to the left a little bit, we want to leave some room there. So this is 3. This is negative 3. I can go out here. This is pi. I'm going to complete one full cycle in pi. Cut that in half is pi over 2. Cut that in half is pi over 4. So pi over 4, 2 pi over 4, 3 pi over 4. But then for my phase shift, I need to shift this whole thing back pi over 4. So if this is pi over 4, that's negative pi over 4. We are again graphing sine. So we're going to start at the midline at negative pi over 4. Then we're going to go up, back down to the middle. We have one full cycle of sine. The period is pi, so the distance between negative pi over 4 and 3 pi over 4 is pi. It's just we shifted the whole thing to the left pi over 4. Okay, so we have 2 sine 3x plus pi. amplitude is 2. My period is 2 pi divided by 3. The phase shift is going to be negative b over c, over b, so negative pi over 3, and no vertical shift. Okay, so we're going to again favor the negative side since we're shifting that direction. Okay, I'm going to start with my amplitude, 2, so this is 2, this is negative 2. Our period is 2 pi over 3, so this is going to be 2 pi over 3. This is going to be pi over 3. This would be pi over 6, since that's half. So my increments are pi over 6. So 1 pi over 6, 2 pi over 6. 3 pi over 6 is the same as pi over 2. So I need to backtrack to negative pi over 3, but my increments still need to go by pi over 6. So this is pi over 6. This will be negative pi over 6. This will be negative pi over 3. So we're going to graph our sine 5 points in increments of pi over 6, starting at negative pi over 3. So it is a sine again, so it's going to start at the midline, go up, midline, down, midline. Okay, so let's do this one. This graph, the amplitude is 2, the phase shift is negative pi over 3. The period is going to be 2 pi divided by b, which is 3, and the vertical shift is none. And if you notice, those two are basically the same, we're just swapping out a cosine. So going from 2 to negative 2, period is 2 pi over 3. Makes that half, makes that half, and then we need to backtrack, negative pi over 6, negative pi over 3. So my starting value is at negative pi over 3, but this time we're graphing cosine. So we're going to start at the maximum, go to the midline, to the minimum, to the midline, to the maximum. Okay, our next one here, the amplitude is still 2, period is 2 pi over 3, phase shift is negative pi over 3, vertical shift is none. In fact, this is the same exact graph, but it's going to be negative. So my axes are going to be marked the same. So we still start out here at 2 pi over 3, or you can just copy those all down since we know it's going to be the same. This is a negative cosine, so it's going to start at the minimum, go to the midline, to the maximum, to the midline, to the minimum. Okay, so we're going to graph 4 sine 2x minus pi over 3. Amplitude is going to be 4. Our period is going to be 2 pi divided by 2, which is pi. Our phase shift, and this should be a 2 here, and yours should show that. So this is pi over 2. So this is going to be a negative pi over 2, which is going to be a positive pi over 4. Okay, so So this one we're moving to the right. So I'll go ahead and put my y-axis here. We're going up to a maximum of 4, a minimum of -4. I'm moving it to the right, so I'm going to leave a little bit of extra space past the pi. So my period is pi. Split that up into 4 pieces, so half and half. So pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and I'm going to continue 5 pi over 4. Now I always do like the half-half just because in my head that makes more sense, but you can take this and just divide that by 4 to get your increments for the 5 points. We are graphing a sine shifted to the right pi over 4. So we're going to start our sine curve here, up, midline, down, midline. Or, like I said before, you could graph to here and then backtrack because this is a part of an infinite sine curve. All right, so our amplitude is 4. The period is 2 pi divided by our b, which is 2, which gives us pi. Our phase shift is a negative 3 pi over 2 over 2. So this number divided by this number. So this is a positive 3 pi over 4. Still don't have a vertical shift. Thinking about how we're going to set this up, we have a positive phase shift. So I'm going to put my y-axis here. This will be 4. This will be -4. Okay. Thinking about how we're going to graph this. Our starting is going to be at the phase shift. We're going to start the graph at 3 pi over 4. And then we're going to cycle pi units past that. So the biggest we're going to be is going to be at 7 pi over 4. So just keep that in mind. This one we're going to label our axes. So I'm going to start with my period. So my period is pi. Cut that in half is pi over 2. Cut that in half is pi over 4. So we have pi over 4, 2 pi over 4, 3 pi over 4. This is going to be where we're going to start our graph, so I need to include quite a few after this, or backtrack. So 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4. Okay, so we're going to start, we have a phase shift of 3 pi over 4, so we're going to start here. We're graphing a negative cosine. So at 3 pi over 4, it's going to be at the minimum. So there's our graph. And again, I keep saying it, but you could, I'm going to do it in a different color here. You could have started at the 3 pi over 4, gone to pi and been like, oh, I'm out of space, and then backtracked. Because this is a part of an infinite loop. So as long as you have 5 points somewhere in here, then you have the graph that I'm looking for. Okay, so these just take practice. Our amplitude is 5. Our period is 2 pi divided by 1/2, which is going to be 4 pi. We have a phase shift of negative pi over 4 over 1/2, which is the same as negative pi over 4 times 2, which is going to be negative pi over 2. Okay, sorry about that. I realized I had changed. So amplitude is 5, period is 2 pi over 1/2, so I had changed this problem. So the phase shift is going to be negative pi over 1/2, which is going to be negative 2 pi. Still haven't gotten to a vertical shift, but we'll do a couple of those soon. So we have a negative phase shift, so I'm going to leave some negative space. 5 negative 5. Period is 4 pi. Makes that 2 pi. Makes that pi. So 1 pi, 2 pi, 3 pi. And then I need to go back 2 pi, but I still need to keep my increments. So this will be negative pi, negative 2 pi. We're graphing a negative sine starting at negative 2 pi. So it's going to start at the midline, then it's going to go down to the midline, to the maximum, to the midline, and you can keep going, but we're good. There. Okay, so now we're going to do one with a vertical shift. Okay. So my amplitude is 2. My period is 2 pi divided by pi. So that's going to be 2. I don't have a phase shift here. Okay, but we do have a vertical shift of negative 3. So we have a vertical shift of negative 3 and an amplitude of 2. So my minimum, this is going to be my midline. We're going to go 2 above that and 2 below that. So our vertical shift is negative, so I'm going to favor the negative side here. I said we have to go down to a minimum of negative 2. So this is going to be 2, 3, 4, 5. So negative 1, negative 2, negative 3, negative 4, negative 5. Here, our period is going to be 2. So I'm going to go out here to 2, cut that in half to 1, cut that in half to 1/2, cut that in half. So 1, 2 halves, 3 halves. Now, how I'm going to graph this with a vertical shift? Because the whole thing is now going to oscillate at negative 3. So I'm going to draw a dotted line here at negative 3. That's my new midline. My amplitude is going to be 2 above that at negative 1 and 2 below that at negative 5. There is no phase shift, so we're going to start here, but rather than oscillating like we have been, just jumping up and down above the and below the x-axis, we're going to go through that same rotation, but our max and our min is going to be the 2 green lines, and our midline is this pink one. So we're graphing a positive sine, so we'll start at the midline, then go to the maximum, back to the midline, to the minimum, back to the midline. Okay, so now we're going to do one that has both a phase shift and a vertical shift. So our amplitude is 5. The period is 2 pi over pi, which is 2. The phase shift is going to be negative pi over 2 divided by pi, which is going to be a negative 1/2. Our vertical shift is 3. So we're going to have a negative phase shift, I'll leave a little space there, and a positive vertical shift. So for my y-axis here, my amplitude is 5, a vertical shift of 3. So my midline is at 3, and we're going 5 above that and 5 below that. So I need at least 8. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So my midline is at 3. 1, 2, 3. And my max and my mins are going to be 5 above that and 5 below that. So up at 8. And down at negative 2. Okay. Now we're going to deal with the period, which is 2. So ignore the green pinks for just a second. So this is going to be 2. Cut that in half to get 1. Cut that in half to get 1/2. This will be 3/2. And our phase shift is -1/2. So this distance back. All right, so everything is here. We're going to put a dot on each of the increments, and we're going to oscillate between all the dotted lines here. So our start of a sine is at the midline. So we're going to start right there at -1/2, and then we'll go through our 5 points. So here, up, since it's a positive sign, midline, down, midline. All right, now we're going to write some equations. So write an equation of sine with an amplitude of 2, a period of 4 pi, a phase shift of 2 pi, and a vertical shift of -3. So I need A, B, C, and K in our general equation. Okay, so 2 of these are easy. Amplitude, 2, which means A is 2, and a vertical shift of -3 means K is -3. B and C require calculations. So the B is going to be 2 pi divided by the period, 4 pi. So that's going to be 1/2. For C, we know that the calculation is phase shift equals -C over B. So I'm going to plug in my phase shift of 2 pi over here equals -C over, we just found our B was 1/2. So to solve this equation for C, I'm going to just multiply by a -1/2. So this is going to give me C is equal to -1/2 times 2 pi is -pi. Okay, so my equation is going to be y equals 2 sine 1/2 x minus pi, close the parentheses, -3. Okay, let's do one more. An equation with an amplitude of 5, period of pi, phase shift of -pi/8, and a vertical shift of -2, reflected over the midline, which means it's negative. So we need A, B, C, and K. Okay, A is 5, vertical shift -2. B and C require some calculations. So B is 2 pi over the period, so 2. My phase shift, -pi over 8 equals -C over B that we just found. So I'm going to multiply by -2. So that'll be a positive 2 pi over 8 equals C. So my C is pi over 4. So just take those and plug them into the general equation. So we have a negative because it's reflected over the midline. Our A is 5, our B is 2, our C is pi over 4, and our K is -2. So these just take some practice, but you'll get there.